So in this lesson, we're going to talk about Newton's first law of motion. By the end of it, you should be able to discuss who Sir Isaac Newton is and what his contributions to the STEM field are. You should also be able to explain what his first law of motion is, and you should also be able to identify what happens to objects using the law of inertia. So who is Sir Isaac Newton? Well, you may already know because he is one of the most renowned scientists out there, but he was born in 1643 and died in 1727. He's an English mathematician and physicist. He developed the 3 laws of motion that explain objects at rest and in motion. He also developed a law that explains universal gravitation. And he made other contributions like contributions to calculus, saying that light is composed of rainbow colors, and developing reflecting telescopes. So, as you can see, Isaac Newton has made many contributions across the board from math to astronomy to the STEM field. So, he is probably one of the most known scientists all over the world in many different fields. So what are his 3 laws of motion that I just talked about? Well, his first law is the law of inertia. This is the one we're going to be discussing today. His second law is the law of force, and his third law is the law of motion. So these 3 altogether describe laws of objects at rest and in motion, but individually they describe pieces of them being at rest and in motion. So let's talk about his first law. This is the law of inertia. It states that objects at rest will stay at rest and objects in motion will stay in motion unless acted upon by an unbalanced outside force. So this is saying that if you're sitting on a couch, you are going to continue sitting on that couch unless you're acted upon by an outside force. So let's say you're sitting on that couch and then all of a sudden your sibling comes up and shoves you. Well, now you were acted upon by an outside force, which caused you to no longer be at rest. Okay, another example would be if you're running. So you're going to continue to run unless you're acted upon by an outside force. So you're running and then all of a sudden you slam into a tree because you weren't paying attention. Well, now you're at rest because you've been acted upon by an outside force. You've hit this tree. So looking at these pictures, you can kind of see that this is a very good overall example. You've got a soccer ball that's sitting there. Someone kicks it and now it's moving, and then it gets stopped by a net. So that's a great way to describe the whole law in itself. But now you're probably wondering, well, okay, I understand that the first law is the law of inertia, but what's inertia? Well, inertia is the tendency of objects to resist a change in motion. So, objects at rest want to stay at rest. Objects in motion want to stay in motion. So, an example that we have created to help with this is seatbelts. If you get in a car accident and you're not wearing your seatbelt, your body is going to stay in motion. Even though you may not think that you're in motion, you are because you're moving with the car. But if the car comes to a sudden stop and you're not wearing your seatbelt, you're going to continue moving and probably go through the windshield. But if you're wearing your seatbelt, it's going to stop you. So it's going to your seatbelt acts as an unbalanced force which causes you to stop. If you look at this motorbike right here, it hits this car and the test dummy goes flying into the car because they don't have seatbelts. So inertia, the tendency of objects to resist a change in motion. So objects want to stay in motion, objects want to stay at rest. So I wanted to talk about this tablecloth trick. Is this magic or science? Well, why do dishes stay on the table when the tablecloth is pulled out? It's science. It's all because of their inertia. They want to keep doing what they're already doing. So if you pull the tablecloth out quick enough, the dishes are going to stay there because they want to stay at rest. They don't want to move. So here's a picture, and it basically is saying that objects in motion stay in motion. This truck has brakes, and if it stops super quickly, this big, huge stone that they had in the back of the truck here, it doesn't have brakes, so it's going to continue moving, and it's so big and weighs so much that it's going to fly through the trailer and into the cab. So let's talk a little bit about how mass relates to inertia. The more mass an object has, the more inertia that object has. So the bigger, more massive objects have a harder time starting and stopping because they have more mass and therefore more inertia. So going back to this, that stone probably weighs more than that truck. So it had a harder time stopping quickly than the truck did, which caused it to continue to move through the trailer into the cab. So let's look at these cars. Which one of these two cars has more inertia? Well, that's a Humvee. Here's a Humvee and here's a VW Bug probably. Okay, I'm gonna go with this one because it's bigger, it's heavier, it's got bulletproof metal and all of that. So that one is going to have more inertia because it's going to have more mass. Let's go through an example here. So if a car is going 50 kilometers per hour and it comes to a sudden stop, you hit something, had to come to a stop because there's a deer in the road, whatever it may be. The people inside are going to continue moving at 50 kilometers per hour unless a force prevents them from moving forward through the windshield. So this is the reason that we have seatbelts, as I've said before. It keeps you safe. It prevents you from moving through the windshield. It acts as that unbalanced force that stops your motion. Because something has already stopped the car's motion, but the seatbelt is going to stop your motion. But, so even though on Earth we can feel the effects of Newton's first law, we don't generally see it because of all the other forces that are interfering. Like, if you're sliding a book across a table, you notice that it slows down and eventually comes to a stop, which with Newton's first law, that shouldn't happen. But because of force, because of friction, it does. It's being acted upon by an unbalanced force. The force is friction, which is causing it to slow down and come to a stop. If you throw a ball up in the air, eventually it's going to slow down and fall back down because of gravity. And again, that shouldn't happen. It should just keep going up. But since gravity is an unbalanced force, which is acting on the ball, it comes back down. But where could we see this taking place? Well, you could go and see it in space. The first law is much more obvious there. There's no friction to slow things down. So an object will follow its path until it's acted on by an outside force. So let's go through some examples now. If an astronaut is in space and throws a rock, what's going to happen to the rock? Well, if you look at it, he's throwing the rock in this direction. So he's in space, no friction, no gravity. The rock is going to continue in this motion until something stops it. So if he threw it inside the International Space Station, it's probably going to hit something eventually, which is going to cause it to stop. But if you threw it out in space, if you threw it outside the International Space Station, it's probably going to keep going until it hits an asteroid or a planet or something. So, objects in motion will stay in motion. Now what about this one? So think of a ball in a cart. You've ever walked around Walmart, you're buying a ball for your little sibling, and all of a sudden you decided, you know what, I'm going to be funny. And you jerk the cart forward. What happens to the ball? Well, generally, you see the ball hit the back of the cart. And that's because the ball is at rest and it wants to stay at rest. So the cart moves forward, but the ball stays at the spot that it should. So that's why it hits the back. It wants to stay at rest, whereas the cart's moving forward. So, these two examples explain objects in motion stay in motion, objects at rest stay at rest, unless acted upon by an outside force. So let's do a little bit of recap. Sir Isaac Newton has made many contributions to STEM. He's developed 3 laws of motion that explain objects at rest and when they are moving. His first law is the law of inertia. It states that objects in motion will stay in motion and objects at rest will stay at rest unless acted upon by an outside force. More mass equals more inertia. And on Earth, it's hard to truly see Newton's first law in action, but you can see it clearly in space. So, key things to remember from this. His first law is inertia. It states that objects in motion will stay in motion and objects at rest will stay at rest unless acted upon by an outside force. So this ends the lesson for today. If you have any questions, as always, write them down in your journal or send me an email or text message if they're pretty important and you feel they need to be answered. Otherwise, have a great day.